Hello students, welcome to our grade 8 mathematics program. We are going to look at our last revision video on the chapter circles. So let us start. Here we have a circle, so you can see that there is a point O found in the middle of the circle. So O is called the center of the circle. Now you have a line. This line touches 2 points found on the circumference of a circle. So it passes through the center as well, and it is called a diameter. So what is a diameter? A diameter is a line joining 2 points found on the circumference of a circle and passing through the center. Now you have a green line here. It starts from the center and it touches a point on the circumference. So this is called a radius. Now, if I produce this line, the broken line, you can see that it is the same as the diameter. So you have the green line which touches 2 points on the circumference of the circle and passing through the center. So you have a diameter. Now we can say that the diameter is in fact 2 times the radius. And as I have said earlier, you have the circumference of the circle, which is also called the perimeter. Now, what is a chord? A chord is a line that joins any 2 points on the circumference of a circle. So you have a circle here and you have a line. This line is in fact called a chord. It joins any 2 points on the circumference of a circle. You have a second example of a chord. Now, what about this line? You can see that this line touches 2 points on the circumference of a circle. It is a chord, but at the same time, it is also the diameter because it passes through the center. In fact, the longest chord of a circle is the diameter. Now, what is the area of a circle? It is the region enclosed by the circle. So the red shaded part is in fact the area of the circle. Here you have a circle with a center. Now you have chord AB. You can see that the chord AB has divided the circle into 2 parts. So the smaller part is called the minor segment, whereas the larger part is called the major segment. Now, what is an arc of a circle? An arc of a circle is a portion of the circumference of the circle. So on this circle, you can see the green part, which is the major arc because it is the bigger part. So we call it the major arc. And then you have a smaller one, which is called the minor arc. The red part is the minor arc. Now you also have sector. So what is a sector? A sector is a portion of a circle. It is enclosed by 2 radii and an arc. So you have a major part, which is called the major sector. And you have a smaller part which is called the minor sector. So students, we have made a recap of the important terms related to circle. We have learned what is meant by the different terms such as center, arc, sector, segment, and so on. We have also learned that the diameter is in fact 2 times the radius. You have some exercises to practice now. We now move on to other definitions. So, the perpendicular from center to a chord. What is meant by perpendicular from center to a chord? It is simply a line that passes through the center and which is perpendicular to the chord, and also it bisects the chord. So you have here the chord XY. You have a line from center, the dotted line from center, and it touches the circumference of the circle. Now this line, this dotted line, it divides the chord xy into two equal parts. That's why we have the term bisects. It divides xy into two equal parts. So this is the perpendicular bisector. Let us consider this circle. So you can see that OA is the radius, OM is the perpendicular bisector, AB is the chord. Now OM is going to divide the line AB into two equal parts. And I can say that AM is equal to MB or AM is half AB. Now, you will recall that you had learned previously the Pythagoras theorem. The longest side to the square is equal to the sum of the square of the two shorter sides. Now, what is the longest side? The longest side is always opposite the right angle. So here the longest side is A. I will have A square equal to B square plus C square. We now consider an example. In the diagram, O is the center of the circle, OA is the radius, and AB is the chord. So if AB is equal to 12 centimeters and OM is 8 centimeters, find the length of the radius of the circle. In other words, I need to find the length of OA. So let us have a look at the solution. Since AB is equal to 12 centimeters, so AM will be half of AB, that is AM will be 6 centimeters. Now, we are going to consider the triangle OAM, which is a right angle triangle. So we shall use the Pythagoras theorem. I will have OA to the square equal to OM to the square plus AM to the square. This gives me 8 to the square plus 6 to the square, which is equal to 100. So OA will be the square root of 100, that is 10 centimeters. In other words, the radius of a circle will be 10 centimeters. So here in this question, you had been asked to find the radius given the length of the chord and the length of the perpendicular bisector. Now, this may vary in different questions, as you will see in the given exercises. So you have some questions for you to practice based on the perpendicular bisector. We now continue with our revision. So we had learned previously that the circumference is the distance around the circle, which is also called the perimeter. Now, what is the formula for circumference? The formula is simply C equal to pi d. Now, we had also learned earlier that d is 2 times the radius. So if I replace d by 2r, I shall have circumference equal to 2 pi r. I'm sure you will remember that pi is 22/7 or 3.14. Usually in the questions, you will be given the value of pi. First example. Find the circumference of a circle of diameter 40 centimeters. Take the value of pi to be 3.14. So circumference is given by the formula pi d. So I will have to multiply 3.14 by 40, which gives me 125.6 centimeters. We now consider a second example. Find the radius of a circle given that the circumference is 132 centimeters. So here we have to take pi as 22/7. Now we know that the formula for circumference is 2 pi r. So 2 times 22/7 times r will be equal to 132. And simplifying, I'll get r equal to 21 centimeters. So you have some questions for you to practice on circumference of a circle. We now continue with length of arc. So we had learned earlier that an arc is in fact part of the circumference of a circle. Now, you can see that we have two parts. We have the part AB, the smaller one, which we call minor arc. And then we have the major arc, which is ACB. So AB is the smaller part called minor arc, and the major arc will be ACB. Now, what is the formula for length of arc? Length of arc AB will be x, that is the angle AOB is x. So it's going to be x over 360 degrees times 2 pi r. How you will remember this formula is simply, since length of arc is part of the circumference, it is a portion of the circumference of a circle, and we had learned earlier that circumference is 2 pi r, so it's going to be a part of this value 2 pi r. That's why you have length of arc equal to x over 360 times 2 pi r. So one example on this, the diagram shows a sector OAB with radius 12 centimeters and angle AOB is 60 degrees. So taking pi to be 3.14, we need to find the length of arc AB and the perimeter of the sector AOB. So length of arc is going to be x over 360 degrees times 2 pi r. That is 60 over 360 times 2 times 3.14 times 12, which gives me 12.56 centimeters. To find the perimeter, I will have to add OA plus AB plus OB. I repeat, to find the perimeter, we will need to add OA plus the arc AB plus OB. So the perimeter will be 12 plus 12 plus 12.56, which is 36.56 centimeters. A second example, the diagram shows the sector POQ. Given that the length of arc PQ is 50.24 meters and the angle subtended at the center is 120 degrees, we need to find the radius. And here we have been asked to take pi as 3.14. So length of arc will be 120 over 360 degrees times 2 times 3.14 times r, which is equal to 50.24. Simplifying, I'll get r equal to 24 meters. So you have a few questions on length of arc for you to practice. We now move on to area of circle. So the area of a circle will be given by pi r square, where r is the radius. Let us look at this example. Find the area of a circle of radius 21 centimeters. Here you need to take pi as 22 over 7. So area of circle is given by pi r square. I will have 22 over 7 times 21 times 21, which is 1,386 centimeters square. Now for the area of sector. So you can see here we have a sector AOB, the minor sector, which is the smaller one, and then you'll have a major sector. So if I want to find the area of a smaller sector AOB, again, this is part of the area of a circle. So I will have a formula x over 360 degrees times pi r square. So for length of arc, it's part of the circumference, and we use 2 pi r, whereas here for area of sector, it's part of the area of a circle, so we use pi r square. Example, find the area of sector AOB given that the radius is 10 centimeters and the angle AOB is 75 degrees. Here pi is 3.14. So area of sector is given by x over 360 times pi r square. I replace x by 75. pi is 3.14 and r is 10. Simplifying, I get 65.4 centimeters square. So you have questions to practice on area of circle and area of sector. You also have some links where you can get some additional practice on circles. So students, we have reached the end of the revision session on circles. This chapter contains a lot of formulae and you will have to remember all of them to be able to work out the questions on circles. What I would advise you is to write down the formula each time you're working out a question on circles. This would help you to remember the different formulae. So until we meet again, it's goodbye.